Welcome to the Texas Panhandle Builders Association TPBA Builder Talk podcast, where we'll bring you expert advice from the heart of Amarillo building community. Whether you're a seasoned professional or just starting in the trade, our goal is to keep you informed on the ever-evolving building codes, share best practices, and help you excel in your craft. From innovative design ideas to smart material selections and everything in between, we're here to support you in every aspect of home building. Each episode, we'll dive into the topics that matter most to builders, contractors, and industry professionals, ensuring that you stay ahead of the curve in this rapidly changing landscape. Our discussions are shaped by the experiences and knowledges of our hosts and guests, providing you with valuable perspectives that you can apply directly to your work. The views and the opinions expressed are those of the host and the guest and may not always reflect the most up-to-date or accurate information. Let's build something great together, one conversation at a time. Welcome back to the fourth episode of the TBA Builder Talk podcast. I'm your host, Jordan Dugan, along with my co-host,
Ben Hardesty,
Joel Rafton for the Duration Homes,
Robert Downing, RDS Inspection Service.
So if you listened to the last podcast, we were talking about wall assemblies. We talked about some not so typical wall assemblies, and it's led us to now our wood framing, which is what's common here in Amarillo. So today we're going to kind of break that down a little bit more.
This is the second half of the cliffhanger.
I
know you guys have been waiting. That last one, I haven't slept in 2 weeks, waiting for the second half to come around.
Just been up all night.
Oh my gosh.
Thinking about the information.
Thinking about that, left us hanging there and without even a joist hanger.
It's, as a builder, it's one of my favorite parts of construction. I don't know if you guys are the same way. I know, Joel, you were a framer for a while.
I did framing. I enjoy it.
I would assume it's one of your favorite parts
fun.
too.
Yep, it's fun.
When we're framing a house, the feedback we always get from a customer, like, man, we didn't know that the house was just going to happen this quickly. I'm like, well, hold on now. We're just on the first part of this. Framing does go quick. Mm-hmm. But yeah, let's dive into, the wall assemblies and the roof and what makes those up. We're going to talk about certain materials, the names of those. So, if we do have a homeowner out there listening or other trades that aren't involved in the framing, they'll know what each individual piece of framing is referred to, what it's called typically, what it's supporting, what it's doing, what the whole reason we've got it there and how it's connected.
Did you want to change your story on the wicking thing again, or are you going to stick with the 6 mile?
I'm still good on the 6 miles.
Okay, then go into the history of framing then. I like that idea.
Yeah, so why do we use wood? In other countries, they use some of those more atypical wall assemblies that we talked about last episode.
The history of wood framing.
So the history of wood framing we have to look at the way that America was started, right? We came in over here on a ship and we needed a place to stay. We had to have shelter from the weather, and so we were using our readily available resources. So now we had Native Americans that were already here.
You can't dub in some like covered wagon noise. Come on, you got tricked.
We had to probably make the covered wagons too.
Yeah, right. The rawhide theme coming in right now.
We had Native Americans here that figured out, there were caves they were living in. There were, of course, the teepee, right? So they were using a natural resource. They were using, animal hide and lumber, the stuff right off of a tree to build up. They were nomadic, moving around a lot more, so they didn't have as permanent structures. As we settled, we started building these more permanent structures. Now, back east, there were some stone, and there were places where we had log cabins and some stone that was going into stacked style. But as we expanded westward, the one resource that we really had that was easily available, easily modifiable to build what we needed to keep us out of the weathered elements was lumber. And a lot of that went into log cabin form because we didn't have the fasteners that we have now. It cost, at the time we could get a nail over here from Europe, but it cost more in tax to get the nail than the nail actually cost to be produced. So nails weren't really an option, which brought us into the log home era of that was the way you typically built your settlement. So that was our old school settlement home that we don't have very much of those around anymore. I know WT's got one.
Yeah.
which is pretty cool to look at. One of our local
I
colleges
think
here.
Texas Tech has one on their campus too, as well.
So that was
Log cabin.
I've lived in them. Quite a few of them.
Yeah.
Interesting enough. They're different.
Once we got some of that settlement established, then that opened up the capabilities of us having a sawmill on
Right, milling
certain
the lumber.
areas. And that's where that standardization came in, to where we could even more easily build without having to go and cut a tree down and delimit, debark it, notch it. We had lumber readily available. Let's go build.
I mean, and going back to those days, you can just see the guys pulling up in the 23 Ford, taking the back tire off and putting a belt on it,
Mm-hmm.
doing the milling, and then putting the tire back on and driving home.
Mm-hmm.
That's how they did it. Portable sawmill.
I think not long after, about the same time we started getting our sawmill, we started having it was beyond just a blacksmith here in America, but more of a production type where we were actually making nails so that we could also fasten those the dimensional lumber that we were having milled out could go up even quicker. So that expanded our westward expansion got even quicker. But it's been a staple here in America, and all we've done is just tweak it, make it a little bit better, make it a little bit more efficient, make it last longer.
Made the wood smaller.
Made the wood
2x4. Oh,
yeah.
geez, it's not 2x4 anymore.
No, hopefully it'll stay where it's at, because we've got so many critical dimensions that rely on that now.
1.5 inches by 3.5. Wow.
Now it's millimeters or centimeters.
But it's an interesting thing to think about, why we frame a wood, why we don't really build stone walls, why we don't have some of those other structures that are all over the world. And most of it is we were in a hurry to get things done, and that was the first resource that was easily usable. And so it worked well for us during the time we needed it. And now we've just modified it.
We're used to it.
Re-engineered it. And kind of rethought the way we were building things to still make it accessible and usable and sustainable and durable and all the things that it needs to be to make the houses that we're living in now.
Yep. So we're kind of talking about availability of, certain species, why we see certain things in this market that, the Pacific Northwest, you're not going to see it in New England either.
Mm-hmm.
Obviously in Amarillo, there's not a whole lot of big trees. So where are we getting our stuff primarily from?
New Mexico? Is that where it comes from?
No, I think we get some of it from Georgia. We still get a lot of it from
the Pacific
from
Northwest.
the Pacific.
Yeah.
Because I'm trying to
You
manufacture.
Canada's got a
ever
bunch.
see Roseburg?
Yes,
lumber
that's
show?
the exact name I was trying to think of
Oh,
just now.
yeah.
There's a lot of Roseburg that's here. All of our LVLs, I think, are Roseburg.
Mhm.
LSLs, a lot of our engineered lumber is
There's
Roseburg.
a town right
Oh,
next to
yeah.
Medford called Roseburg, right by the Rogue River.
I think at home of the Essential Craftsman. You guys ever heard of him?
No,
That's a pretty cool guy.
huh.
Anyways,
Cool place.
yeah, that's where a lot of our stuff comes from. And I think a lot of the other half of it's coming from Georgia area. But most of it we're back over toward Oregon. But our availability of it, is that one of your questions that you were asking? Why? It's regional. So of course the guys over on the East Coast are using a different species. Guys on the West Coast are using different species. That's typically where our two sources of lumber come from, and it's a manufacturer and supply issue, what we're going to get here
And what it's going to cost.
and what it's going to cost to get here. And so as a builder,
or else it's that finger jointed lumber that isn't a species at all, or it's a combination.
combination maybe. Yeah.
Right. And we see that here in town.
And it has nothing to do with the builders selecting it. It's what our suppliers have available.
Availability.
Yeah.
Yeah.
So I'm sure the different species of wood will have different characteristics. Is there a particular reason you would use, a yellow pine versus a Doug fir?
Well, longleaf yellow pine is not available anymore.
Nope.
That's what you saw in the old buildings, which we had here. There are buildings that have it. It was kind of the premium lumber, the old growth, really hard, really durable. In fact, we've been really good at sustaining our forestry and our harvesting off of it and regrowth to make it sustainable for the environment and for the economy. But in turn, it's kind of changed the properties of our lumber in so much that we've even had to change the building code span charts because of that lumber.
Yes.
Yeah, from an engineering point of view, you'll get spec'd out a certain type of lumber that's engineered for what you want, and other lumbers wouldn't qualify.
Mm-hmm.
And that's the engineers specifying Douglas for number 1 in this location for a bearing reason or something.
Okay, perfect. So that gets us into the conversation of number 1, number 2, and common boards and all that too. So
yeah, and even before number 1 and number 2, the difference between hemlock and pine and Douglas, they even have their own section for spans. So
yes,
and I'm not familiar enough with
denser.
I'm not familiar enough with them to tell you which one spans further. I've always got to look back and look at those charts. But some wood is denser and has more of a load rating capacity.
If I remember right, Doug fir probably spans further than anything else we've got.
It's graded that way. And it's interesting enough and also if you, let's say, aside from all of this type of wood, and you wanted to take the wood off your property and you wanted to mill it and you wanted to make your own house, you can have a guy come in and he'll grade that wood.
Mm-hmm.
I've had it done. He comes in, he grades it, because if your house is being built in a jurisdiction where you have to have a permit and you have to inspect it, it has to be rated
Got to
wood.
be stamped.
Mm-hmm.
Yeah, and so, but you don't want to go to the lumber yard when you have your whole property is full of lumber. So you'll drop your trees, you'll bring your portable mill in, you'll mill it, and you bring in your inspector. He'll inspect it for density, straight, and he'll stamp it, and you can use that wood. Right
just stamps the whole bunk that you just.
Well, I can't
pulled
give
out.
you the certification sort of letter that you're good for your permit. He's not going to stamp each piece of wood.
Yeah,
Yeah, right. Take some
gotcha.
pictures. Well, now that's kind of a cool thing.
Yep.
I've been involved in that a couple times.
It's an interesting thought. I wonder.
Again, something we're not used to regionally with not having.
No, we don't have anything
Not having
here.
lumber on site. Because you're going to clear your lot to build your
Mhm.
house, and you're going to end up with a pile of trees. And there's plenty of portable mill guys that come out and whack it into pieces.
The manufacturer is responsible for grading that and then sending it to our local suppliers.
That is
Right.
I wonder how much that grade changes during that shipment and by the time we actually reach it.
There's
I mean,
no
we
way.
talked about on the last episode how much we're having to cull, whether it's 10 to 15% or whatever it is, but we're also not out there judging the actual grade of that lumber. And I wonder if it's gone from a number 2 to now it's a number 3 or whatever. It's interesting.
Well, part of it has to do with the wane
Mhm.
or with the the bark roll, if you will. We call it wane. Why do they call it wane?
That's just
Is that guy's
common
name back there? Hey, Wayne, give us. Anyways, so if it's kind of all rolled on 3 sides or 2 sides, that's a great issue as well.
Mm-hmm.
You're thinking, why would it change in transport?
Just
I'm thinking
exposure.
dry. I think it might dry out a little bit more.
Well, if it's kiln dried, it wouldn't dry out.
Yeah, but kiln dry now is not like kiln dry used to be.
Yeah.
It's like kiln dry now is express kiln dry, and that's not completely.
Right, air dried and
It's really not good. It's just good enough.
good enough for a stamp.
Yeah. I mean, how many?
And a stamp and a buck.
Yeah. I know there's an optimal framing moisture that you want to have when you're framing a building that probably isn't, given any thought when by the time it comes over here, which I think is under 18%.
I think it's 12%.
Is it 12%?
I think it's 12%.
12%, which I don't think we have an issue with that because our wood dries out so quick.
Right? That's an issue in its own self.
Right.
We might have the opposite, didn't have enough moisture.
Right.
So with all this wood that we're talking about, it all turns into studs. So everybody knows what a stud is. What different classifications do those studs
You're a stud.
actually? Well, other than me, of
Oh.
course, that was a given.
Yeah.
But so we're obviously making walls out of this stuff.
Mm-hmm.
Where do you start with that?
Well, with Joel's history, you typically start with the floor assembly.
With a post and beam or pier and beam, as it's called.
Mm-hmm.
Right. Here we start with a concrete slab and
Yeah.
pressure treated
Steel
lumber.
plate, yeah.
Yeah.
What
Well,
I
actually, before the pressure treated lumber is the goo you promote. What's that called? Your sill sealer.
Yeah.
What's your favorite brand of the week?
Lexo.
Yep. Lexell's my favorite.
Made by Sashco.
Made by Sashco. Yep.
Yeah, we've had really good experience with it.
So
good product.
Even if it's pressure treated lumber, we still don't like to go direct contact to the either stem wall or the slab. But
capillary break is the way that was what the
break.
And why do we have that capillary break?
Capillary breaks help stop the moisture from waking up into the.
They can go up
6
how
miles.
far?
Yeah,
That's where that 6 miles
we're
come
back
in.
Yeah, there we go. We're
Aren't
back to 6
Aren't you
miles.
glad I dropped that seed for you?
The other thing that
That's a
stops
freebie.
that we've talked about before is the vapor control layer that should be going underneath the
Joining.
slab.
Yep, true.
Yeah, that's a whole nother conversation.
We've had it.
We have
we've had
it.
So in Joel's case, he's used to starting with the floor framing. I'd like to see more of it. We've talked about that here on the show as well.
They might come around.
Makes sense, and I think it's a great assembly. Joel, why don't you talk about what was your common floor assembly?
Well, it's a stem wall. We would do a typical 2-foot stem wall.
Mm-hmm.
So by the time whether you're dropping your beams in the crawl assembly or putting them on top, I think the code is like 18 inches below the lowest hang me down.
Mm-hmm.
And so, first off, you would line the whole crawl space with the 6 mil black plastic for the vapor barrier. And then it could be a right on the stem wall, or if it's a slope lot, you build your pony walls, and you could have 8, 10, 12-foot pony walls to the actual finished floor height, depending on how much contour in the land falls off.
So are you on, as far as your floor, were you typically using trusses, or were you using solid sawn lumber, engineered lumber? What were you
It's pretty standard small house. You would use beams,
Okay.
and then you would use 1 1/8 plywood.
Okay.
And was that spanned 32 inches or something like that?
Yeah.
So you would either have beam pockets in your actual stem wall, which is pretty common. Let's just say bare basic common.
Mhm.
You got a standard stem wall that's the same height all the way around. It's a flat lot, and you'd have beam pockets, and you would put the beams in there if you were so inclined and you wanted to have an eye joist. They actually make a little form that goes in the stem wall, and you can have an eye joist pocket.
Mm-hmm.
And then you throw all that in there, and it levels up right with the pressure treated, the 1.5 inches that you bolted down the sill sealer, and
Yep. The 1.5 inches would be your sill plate at this point.
and then at that point your plywood goes right over, and then you're back to ground zero like you would be here with your slab on grade.
Sure.
And then you're not using a pressure treated bottom plate anymore.
No.
You're just building a standard wood wall.
The only other alternative to that would be using trusses, and then you could even have it'd be either a bottom cord bearing or a top cord bearing truss on the floor.
Yeah, open web trusses.
Mhm.
You can
Because you mentioned TJIs.
yeah, or the open web truss you probably wouldn't drop in the hole. Probably set those right on the top of your pressure treated lumber.
Depends if it's
with a rim board.
depends if it's a top cord bearing or a bottom
Bottom
bearing.
cord bearing. Yeah.
So a top cord bearing, it would drop into your.
But then you'd have difficulty getting your 18 inches sometimes.
Yeah.
But anyway, so and then after that, then it's back to standard framing.
Mm-hmm.
A pier and beam can be built in a standard, pretty basic configuration, 3,000 square foot house with a 2 or 3 car garage in about 5 hours.
So if we've got a bottom bearing truss, you're going to have what I would refer to, and there's another common name for it I can't think off of, but rim joist around that, correct?
Yeah, the rim.
There's another name for it.
I don't think so.
Or a ridge band.
Band, yeah.
Band's the other one.
So you're going to
Well,
have.
if you're doing trusses, you can really get away with just a top band,
Mhm.
but then you end up with air infiltration issue. It's just as easy to do the rim,
Yeah.
And it's a box, basically a really
Yeah.
nice looking box sitting on top of a pressure treated sill plate.
Yeah.
And then off you go, and then your plywood would expand down to the sill plate or a little below, maybe an inch below, and they would nail out to the sill plate and pick up the beams or the trusses as whatever's there.
And typically those were in the past they've been vented crawl space, and we've moved a lot to unvented crawl spaces now.
Yeah, I have moved because of some of the energy efficiencies and the conditioned crawl space, but it just is only within 3 years ago when I've left and the Northwest, and I can ask some of my friends, we're still There's still venting crawl spaces.
Mhm.
Maybe it's a moisture thing.
Yeah,
Over there,
I know they're working toward.
We're dry here.
On the HVAC side of codes is probably eventually going to see a HVAC plus D added to it pretty soon for dehumidification and a lot. We don't have it here because we're
Not in our
so
climate
dry.
zone.
But they're I think they're moving to having, if you've got a sealed crawl space and a sealed attic and your house,
Mechanically, you got to make it up.
maybe even actually having 3 different dehumidification systems or a complete whole house underfloor and over ceiling.
Sure.
Because I agree that once they get over 60% humidity, you get a real big problem in those crawl spaces.
Sure. And then also there's something you don't see around here is groundwater.
No.
And that's an issue of its own self is out of nowhere, right under your house, the spring pops up.
Mm-hmm.
So there's a whole, in digging those types of foundations, there's a whole low point drain system
Mm-hmm.
that has to daylight or it has to be sump pumped.
Right.
Mhm.
And that's a standard as, making a pie.
Mhm.
Wire up, there's going to be a sump pump there.
Mm-hmm.
I need a circuit under there. And if it's not there now, it's going to be there someday.
Mhm.
So there's companies, just like you have companies here in town that would go through and jack up the foundation, put their,
Right.
mitigate all the cracks and stuff. There's a billion companies that would crawl into the mud, get in there and before you actually build that floor system, you do grade, even though the foundation where it sits is level, you grade the crawl space right before you start bringing the wood in. So it rolls to the low point drain just for groundwater coming up that it can all head that direction.
Sure.
And there's a little flapper valve, typical drain system.
Mhm.
And it goes, if it can't daylight out, if you're not like you have to be on a slope, then you're gonna put a big bucket, a big hole there, a big sump pump, and you're gonna pump it out, and it's kind of a
Make sure to test it because
another whole
heard that
subject.
Which is very common everywhere else in the United States,
But
here, except for
Right. I mean, you can even in some jurisdictions you have to have an alarm
Mhm.
that we beeping up in the kitchen or something.
Mhm.
Hey, the sump pump's on. Oh, great. So that was just a little throw me in, but that's your base. And there again, if it was a real slope lot, you would build stud walls, sometimes double stud walls, depending on the engineering to get up to the actual floor.
Right.
Sometimes 10, 12 feet high. And then you're at the floor at the back of the house. If the slope goes that way, at the front of the house, you're at grade
Mhm.
because the slope falls away. So, or if it's the opposite, then that front of the house is standing 12 feet high is a suspended garage slab.
Mhm.
You're actually driving on a wood floor with light and concrete.
Light deck.
No, just concrete poured
Just
right on.
Mhm.
Car decking, 2x6s, tongue and groove car decking. Probably
Car
number
decking.
I've
2. Never seen car decking.
You have it.
You just didn't know
It
it.
isn't called car decking it probably, I don't know why it's called car decking, but it's just one of those terms. Actually Jordan was asking about after you do this floor system. And I said, well, we use an inch and innate, engineered plywood, but that's of more recent years. Before that, you would take this really number 3 grade, bottom of the barrel 2x6 tongue and groove material.
Mhm.
And there was a tool that you stab the joist and it would tighten it up. It would pull it tight and you'd nail it and you go to the next piece and you can go 3-1 and stagger. It was a whole stagger pattern. You would build a floor system out of junky wood.
Huh.
And then you'd put underlayment on top of it for your vinyls and your carpets.
Yeah.
And they gave you that smooth back again. And we built like that for years and years and years. And then the inch and an eighth nice plywood shows up, which is underlayment and structure wood all in one piece. And it's a sheet and it goes down nicely. But
Mhm.
before that, it was this car decking. So if you are going to build a suspended garage slab, you go back to that car decking and you put that car decking down and then tar paper and concrete, and you're actually driving on a wood floor 12 feet in the air.
That's pretty fun.
Yeah. Anyways, that's enough of that. Now we're into wall systems.
So we got
the walls.
we got the below wall system kind of
Right, the floor
labeled
thing.
out. And there's a couple things to touch on that we'll get into here in a little bit when we talk about connection points and nailing patterns and I guess the things that go into making those things hold together, right? So we're going to start here with slab on grades. The first thing we're putting down is our seal plate.
Mm-hmm.
In our case, seal plate's always treated. It varies on the size depending on what kind of wall you're putting up, whether it's 2x4, 2x6. I think 2x6 is about as big as it really often gets here. What else do we have about the seal plate?
So how on the attachment to that? I mean, assuming you got J bolts and stuff installed.
You can use J bolts. You can use the HD Titan bolts, epoxy, and they're actually the way it was explained to me by Simpson Strong Tie was the way we use wedge anchors for exterior. That's not what they were for. They're not supposed to be used for that. And as a matter of fact, they have a whole new, they've had it for 2 or 3 years. They talk about some of the J bolts and start talking about the HD Titans as being supposed to be the acceptable engineering for that
replacement,
not wedge. The wedge anchors came because it's just something they do here as a regional. The wedge anchors don't hold for what
they're everywhere. But for Simpson Strong Tie, depending on where you are in the engineering, requires your epoxy and your pull tests. Which is really another whole hassle in itself. So you're talking about the J bolts. Well, every concrete guy forgets some. It's just the way it is. And so there has to be a way in the field you can add them. And the wedge anchors are not a good way to go. No. And so you're talking about the new ones are the screw-in guys, which I still don't really know, but it's a mechanical screwed-in affair. And I guess it's okay for a sill plate if you're missing 1 or 2 in the field. There is a code on how many bolts have to be spacing and if there's a splice in your sill plate, because obviously there's a splice. This isn't 60-foot goods here, right? And so many inches off the splice, and that's all a code. So
in corners,
so the chances of your concrete guy getting it right aren't very good.
No,
well, and that's in defense of him.
What they really do is they'll go off of their what 6 foot spacing, and they'll just plug these things in the concrete while it's wet, and they never look at the plan. Oh, you got a slider door going over here. You got an in wall coming up over
usually
here.
they're in the front door. You have to cut them off or something.
You got to cut them off, and then you've got to add some by usually the door.
Right. But if it's if it's just a standard one in the field where it isn't a deal buster, but if it's something that really needed to be there for any kind of engineering, any kind of pulling, and they missed it, then you have to have drill a hole, get special glue, right, epoxy glue. And then you have to pay somebody to come out and watch it being installed. So they actually take an air nozzle and they clean the hole out and they measure it. Then they look at the numbers on the epoxy tubes to make sure that they're not expired. They put it in and then they apply this missing piece. And then after so many days, they come back and they do a pull test.
Yeah, we don't do that here.
I know you don't. but that's because this is in a seismic zone.
Yeah, exactly.
In
we're not.
In a seismic zone, when all that stuff counts,
it's
a hassle when they forget one. So as a builder, you go through and you spray paint your dots and you make sure they don't miss them because you've had to do that whole pull test hassle. It's like, learn me once and I'm sure I won't fail this again. Your building inspector just gives you this little note. Pull test required. You go, oh no, not a pull test.
Yeah.
So you go back and you mark them all. But around here, they use
we're seismic zone B, which is basically non-existent. So
it'd be nice to probably get away from our wedge anchors, but again, I don't think we got to push for it.
No, nobody's. I mean, pressing it. I would rather they didn't use the wedge anchors. Because to begin with, they're not long enough anyway. And it says in the code book, you got to have 7.5 inches. And we don't even get close. That's 7.5 inches
in the concrete.
Below the inch.
So it's below the inch and a half plus the nut, the washer, and all that stuff.
You're 12-inch J-bolt.
Yeah. No one's got the drill bit.
So and I'm assuming a ram set would not.
No.
So moving on from our bottom seal plate, other than we want to talk about seal sealer or the adhesive or anything like that.
Yeah, I mean,
we can get in that with the air control layer as well.
Yeah, it still calls for a separation between the concrete and the bottom plate, so it doesn't. I mean, there's all kinds of ways to skin that cat, and some use a liquid, some use a gasket type material, some use a foam material, which
so code calls for how often you see it in Amarillo.
Oh, they just kind of throw something down. It's just a 3.5-inch foam
piece of
cheap foam. And they say, well, that's part of your air seating. No, it's not. Doesn't even get close.
It's hard to air seal something that's not perfectly smooth on both sides.
Absolutely not.
With a 16th inch of material.
With 60-mile-an-hour winds.
Yeah. No.
That's the kicker.
Yeah.
No. So anyway, we haven't ever seen, I think one of the manufacturers I ran into, I believe is Protecto Wrap, that actually builds a true gasket.
Yeah.
And it's a pretty cool product, but it's not, it's not nickel a foot or 2 cents a foot.
We often use that Lexel product that you were talking about. And a while back, I remember Milwaukee came out with a battery powered caulking gun. I'm like, man,
that's pretty cool.
Who would spend, almost $300 on a caulking gun when you go buy, boxes of caulking gun for $300? And when we first started moving to using Lexel underneath our sill plates, and I went through like 3 boxes of Lexel in less than 45 minutes, we went and bought a couple of those guns. And yeah, they'll run through it pretty quick, and it changed the game for us. And so I like it because it's like threefold. You're getting a good capillary seal or capillary break. Yeah. You're getting a really good air seal.
And it's still less expensive than using another product. Using acoustical sealant is another one.
And less messy.
Yeah, and less messy. And acoustical sealant works really well, and it never dries out, but it's messy and it's expensive.
Well,
and that's part of.
So we were talking about how your concrete guy sometimes doesn't look for your door openings.
Yeah.
And sometimes when they're initially starting out on wall framing, they'll still plate the whole dang wall and not cut that, because they're keeping that wall square. So they're not going to cut that bottom connection out, sill plate out. So we've had like a 8-foot slider door where that 2x6 treated plate got Lexel down to the ground. And I can tell you that stuff sticks really well to a treated plate and concrete, to where you've got to have a hammer and a chisel to break the rest of it off. So you do get some hold down with that also. So that's kind of your,
that's a double whammy.
Your three things you're getting out of it. That's one reason I really like using it.
Yeah. I like Lexel. I think Sashco as a whole is a good company, and they build all kinds of products for all different needs. So it's not, I mean, Lexel and Big Stretch are their two biggest.
The 2 big ones. They got
they've got some roofing stuff.
Through the roof. They started out as a window glazing company. Did you know that? Anyways, so from that seal plate and the attachments, the things that go with it, then we're moving up to our standard stud wall. Right. Here we're going to see 2x4 and 2x6. Spacings are commonly 16s. They can be 16 inches on center from stud to stud. They can be 19.2 on center from stud to stud. They can be 24 on center from stud to stud. And I mean, technically they could be 12 inches if you wanted to put more material in the wall.
Or if it's a balloon wall, you might have to.
Yeah.
Yeah. I was going to say a balloon. Yeah.
Yeah.
Balloon wall, you could.
Before we get into the other components of, jacks or trimmers and cripples and ceiling joists and all that, is there anything else to say about the studs? We want to talk about some of the different types we can get. We got T studs.
Oh, when you're talking about T, the thermal brake studs.
T studs are basically, for like a 2x6 T stud, I think it's 3 inches on, or maybe 2.5 inches on one side, 1.5 inches on the other. And it's connected with like a wooden dowel in between, so that when you insulate,
it looks jicky, but it's not.
Right. It's a super solid wall allows
wall,
insulation between that framing member. It replicates a double stud wall, but the ease of installation is like only putting up a single stud wall.
Right.
Now, a double stud wall would be technically having 2 sill plates and 2 stud walls side by side, so that you can stop the thermal transmission, right? It gives you a thermal break between those two
Or else
studs.
it's a 2x8 bottom plate and stagger studs.
Or stagger studs.
stud.
That's
Gives you the same-
again,
same
2 by
program.
6, you can stagger stud
You can-
too.
which
But
Yeah.
we talked about this a couple of weeks ago, and it's a great idea, but it's kind of inconvenient because your layout gets more difficult, your windows get more difficult, and you're still, it's like you're building two walls.
right.
That's the good thing about the T studs is you're getting all those same benefits but
With
you're-
one wall.
but you're building it like a standard wall.
Yeah.
So it has a material, an insulation material in between what's
No,
effectively.
it's like a wood dowel so that you can get insulation between
okay.
those two strips.
It's not solid.
Mm-mm.
Okay.
It's not solid. It's the dowels are in a X pattern,
Mhm.
and
You buy them in lumberyard.
you can order them.
You order from T Stud. I don't.
Yeah.
I've not got them. I would like to try them out. I think it's a great idea.
I think you order them direct.
Yeah, and there may be a supplier that gets them as well. I'm not real sure. Maybe we'll see them down in Austin when we're all at the Build Show Live here in a few weeks.
Yep.
So we've got LSL, LVL studs, finger joint. Finger joint is like anytime I get a stud over 9 foot, it's commonly a finger joint here. You can spec them on an 8-foot stud if you want to. They're good thing about them is they're straighter and more stable than a standard stud. They're a little bit more than a standard stud. LSLs would be the next step up, which is kind of like a kind of an OSB looking stud, the oriented strand stud, and then LVL is a laminated veneer, which is more like a plywood type of stud. And then both of those, well, the LSL can be treated also. LSLs are better on exterior walls. LVLs.
Yeah.
LSLs are better on interior because they don't have. If they come into contact with moisture, they're almost instantly ruined. Where LVLs can withstand it a little bit more, and then a treated LVL, it can kind of maintain moisture contact and be somewhat okay depending on the circumstance. But those kind of range in price. Standard stud is $3, $3.50, whatever it is right now in the current market. Finger joint stud is going to be probably 10% more.
There's probably a 10% benefit than what you're saying before about how dry it is here and how things twist and
so what's
tweak.
to me, I'm like Joel. That 10% almost is
worth it.
Well, yeah, it'd be really worth it for sure. Because by the time you start trying to hack and chop and twist things and get your framer back and take your full day with your 10-foot straight edge, trying to make sure your mirror walls are straight and everything else, it's not worth it.
Now they're good for vertical load point, but they're not good for horizontal load point.
Right.
But
no doubt.
LVLs and the LSLs are what's better for a.
It's so in like grade from top to bottom, LVL is the premier, and then LSL is the step down right below it that's a little bit cheaper, and then you would go to a finger joint, and then you would go to a standard stud. I think most everything here is a standard stud. You'll see some finger joint. You never ever see a LSL or LVLs.
I've seen them in
person,
2 or 3 different
really
builders'
tall
houses here, but they're typically like in a 20-foot entryway
with a level 5 finish or something.
Yeah, or a big kitchen,
specialty walls.
I've never.
Not a house.
I've never seen them on a kitchen. It makes sense because you get a perfectly flat wall. But I feel like the better use for them is on something where you're going to have a level 5 finish that's really tall. Because if you've got a good cabinet installer and you've got a good countertop installer, that kitchen wall not being perfectly straight can be hidden very, very well between those two. And you're going to spend a significant amount of money on that kitchen wall.
It's true.
And then the craftsmanship of your cabinet and countertop guy can overcome
what little bit of bows are going to be in there anyway. And if you don't like the bow, then slap up some 5/8 and move on.
Yeah, that's true. and that's something we try to do before we ever sheetrock is go through the house and check for anything that got put in that shouldn't have been there. And I've got a hand planer. I've planed down some spots before, or
I've seen the guys do that.
There's furring strips that you can put on them before you put drywall up to keep the wall straight. And so we'll usually try to run a 6-foot level down. And if it catches, then we're looking at that stud and either replacing it or fixing it. Anything else on the standard studs, standard and not standard studs?
Yeah.
Nothing rings a bell.
Well, let's talk about our openings, right? So the next thing that happens in the wall, then I guess we'll just work our way up and go top plate and joist and all those things.
Yeah, not that we should really elaborate on it, but there's a whole world of notching and drilling studs that's not really pertaining to actually building the wall, but that's another thing altogether.
And we have issues.
Yeah, everybody has issues.
Maybe we'll talk about that in our mechanicals and rough ends. What's allowable and not.
Yeah, I'm good with that.
We'll call it the hack and chop episode
because that's when it would that's when it would happen.
That's a great name for that hack and chop.
That's when that's going to happen. It's going to be in the mechanical. So we'll make a note and address
mechanical, plumbing, and electrical.
Right.
But anyways, openings, you have to get in and out, windows and doors. You got a hole in the wall.
Yep.
Make a hole.
So what's the components of those holes in the wall?
Well, there's king studs, there's headers, there's typically different kinds of headers. If we're talking about the advanced framing, we want a box header. So we can get some R value and
so what's the box? Bridging. What's the box header?
Well, it's rather than just putting let's say it's a 2x4 wall, and a lot of the old school ways, you take a 3.5 by 8 or 3.5 by 10 solid wood header, and just that's what would be holding up the bearing load from above, whether it's a floor system or rafters, whatever it is. But with a more advanced thought process, you want to get as much lumber out of the wall as possible with that thermal bridging and try to get more of the energy ability.
I like the term that you used on that, advanced thought process, because that's all it takes. Just a little bit of thinking to do something really smart.
Yeah.
And so you would be typically a king stud and a trimmer setup, but
or referred to as a
jack stud.
That's right.
Yeah. A trimmer or jack stud, and then you would just put your solid member flush to the outside, allowing the inside to a cavity. And nice if it's a 2x6 wall, because it's only an inch and an eighth of solid member on the outside. That gives you a lot of space to fill it back up with.
Yeah, I don't know.
It's an engineering issue of what you can use for that span.
You can technically do it in a 2x4 wall.
Yeah,
but you're not gaining very much out of it. And
you're gaining
some. You're gaining an inch and a half of insulation is what you're going to get. And before, if they weren't even using a solid 3.5 by 8 or whatever lumber piece, they're using 2x6s.
Right.
And so you're still making a box out of that one 2x6 that allows you to have that null and void of one 2x6 worth of insulation.
Well, and just as importantly, again, is the thermal bridging. I mean, that's a lost thought that we have to keep on reminding everybody what that means. And sure, you got a cavity, put insulation, that's good, but the
thermal break is what's key.
It's key,
and it's just more effective on a 2x6 wall, where instead of getting an inch and a half of insulation, you're now getting 4 inches of insulation.
And if you want to do some closed cell, you're getting some real R value out of it.
Yeah, absolutely. Absolutely.
I mean, you could still do the double 2x6, but you'd have to stick a piece of 1/2 inch XPS or a poly ISO in between the two, and they still accept that.
But if you're doing two, on a 2x6 wall only, but you couldn't do that with a 2x4 wall.
I don't know. I'm seeing 7/16 OSB,
but you wouldn't gain anything out of it.
Not really.
2 2x6s and 1/2 inches is 3.5.
Right.
And so you're back to might as well. There's nothing there.
There's nothing there to do.
You haven't gained anything.
So that's kind of the header topic, right? So we've got engineered lumber that we've seen in headers. We've got solid sawn doubled up lumber that's in those, and then there's box header styles. Something else that's even unique is there's header clips that you can use so that you're not even using jacks or trimmers. So you can reduce that amount of wood in the wall on advanced framing. But let's refer to that again. A king stud's a full size stud. So your jacker trimmers are what's supporting your headers. Those are the shorter ones that your head dies into the headers. And then we have what we refer to as cripples, which are the really short studs above the headers or below windows.
Below the windows, yeah.
And then for the windows, we also have the rough opening of a window. So we've got a window sill, which is what the window would rest in or on, depending on what
It's just on the cripples.
It's right on top of the cripples. And then that's kind of the makeup of a window, and the door is basically the same thing without a window sill and cripples below.
Right.
So I'm assuming the cripple is there to effectively be load bearing, or is it there to make sure the spacing is accurate?
It is. So it's load bearing in the fact that you're bringing down that distributed weight on your centered path, right? So you're either going to have 16s, 19.2s, 24s on your centers. And so you're going to continue those for two reasons. One, so that your top plate has a continuation down to that load-bearing header. That load-bearing header can then span more than your top plate can, and then it will bring down into either the clips onto your jacks or to your kings, or it'll bring down the weight directly onto your jacks or your trimmers.
Yeah.
And it's just layout to fill in.
That's the other part of it.
You got your sheeting's going and your sheetrock's going. It's got to make layout, and so you have to fill in the bottom of the window.
So you
have to think about that layout because Energy Star is now requesting that we take part of that. A lot of those cripples out that we're seeing under 3 and 4 foot windows. Well, you don't need them anyway.
No. Maybe one
at the most.
Right.
But we're seeing 3 in a 3 foot window, and it's like
the layout where you're coming from and where you're going to.
Yeah.
And you need your 4 foot where your split's going to be. The rest of it, you got your 2. I guess we'll call them mini jacks to hold the sill up. And after that, you don't, depending how his layout's going, you don't need much more.
Yep.
I mean,
you're done.
Yeah. So just to
clarify, these guys just start filling it all up
on your fillet. You're talking about, to clarify, it's where your outside sheathing seams would meet, and you've got to nail the edge of those seams, and so you need a nailing surface, and that's what that cripple would be for. Same thing on the drywall side, where 2 pieces of drywall meet together. You need to be able to screw those ends in.
Right. It's just to be part of your layout.
So we've got doors and windows kind of covered now. I think we've talked about some of the nuances and the materials and the names of those.
Yeah, something else on doors that I don't see too much around here, but maybe occasionally, garage man doors, right? That's a kind of an important thing. So when you're you guys do much in the way of garage man doors?
Garage man doors. It's like
well, you do in your steel buildings, but a man door.
Okay.
Right.
But I mean, the garages here, we see a few man doors, but they usually go to the backyard. It's not. We don't see a lot of unattached. There are unattached. I'm not going to say there's not any unattached garages, but most everything we have is attached garage.
Right.
Or if it's not, it's a metal building.
Or it's a metal building.
But everybody's going in and out of their overhead doors. Which
there's
walk-through doors on them.
Well, that's what I call man doors.
Yeah, they call them man doors.
So
those are referred to as walk-through doors for the listeners that were.
If you're going to walk through a door out of a garage, depending how they've done the foundation,
sure,
you might be taking that door and putting it right up against non-pressure treated lumber. So there's a couple of little framing nuances there you should pay attention to in your opening for your door.
So you're supposed to use pressure treated around
any kind of concrete to wood contact. Pressure treated.
And why is that?
Why not?
Because it's 6 miles away.
That's right. I was just gonna burn that one. Get that one down. Nobody's gonna forget that.
So we've got windows and doors.
Windows and doors.
And so now we need either a floor above us or a roof above us.
Well, and we've kind of not talked about the top plate, even though it's a key to have before we really even have windows or doors.
We didn't even catch the bottom plate, actually.
We did talk about the bottom plate.
We talked about the pressure treated bottom plate, but we really didn't catch the actual bottom plate of the wall, the layout plate.
Yeah.
Not a big deal.
Yeah.
So there's always a bottom plate and a top plate. There's a top plate.
Yeah.
So that interlocks the walls together. That's where you're at right now.
There's the the bottom plate, the bottom top plate, the top plate.
Yeah.
Yeah.
There's
So you got double.
I don't typically see a lot of double bottom plates here.
No.
No.
The only reason you
don't.
would see one is if for some reason you needed an extra inch and a half because something got screwed up.
Or floor insulation.
Yeah, or maybe it's just the way it lined up from the garage to the house or something.
There's
no reason for it.
Or if you wanted to nail down wood surface floor, that's another good one where you can do 2 bottom plates and then you can layer 2 5/8 staggered sheets on the floor.
Mm-hmm.
Then you've got a nailing surface for hardwood. Or you can do
about that.
You can do
so two bottom plates. Oh, and you would toenail your sheets into the perimeter.
glue down. They would sit inside that first bottom plate. That's your inch and a half.
The second bottom plate's for you to nail your base to. Is that what you're saying?
Correct.
Okay.
Correct. And then if you did a floating, you did a floor just like that, but you had like a foam board insulation underneath it, then you would have to put blocking in at the bottom of the wall. But then at that point,
raft, doing a raft.
Yeah, that'd be a raft setup. At that point, you're going to have, potentially 1.5 inch foam insulation, closed cell foam insulation below it. And so you have like a R10 below that insulated floor and a nailing surface, which is it's a pretty cool idea. It's done once around here that I'm aware of.
Maybe.
I know of one for sure. Stephen Basic's house.
Yeah, that's right. Yeah, out off of VFW Road.
Yeah.
Which is bad when they know what house is done like that.
Yeah. It's hard to convince our clients that it's a good idea because it does cost money, but it is a good idea.
I think
at that point, for a radiant floor. I know we don't do much.
Absolutely, yeah.
So you would.
So that's the other thing is our radiant floors, and we'll get into that in the mechanical makeup. I've seen a lot of radiant floors that have 0 insulation in it, and it's like, well,
that doesn't work.
You just wasted 80% of your energy efficiency because the ground is absorbing all of your heat at that point.
Mm-hmm.
But yes, if you were to do, there's warm board, there's products that are made specifically for it. But if you wanted to do something like that, it would work very well with the floating raft. Type floor insulation system. So back to the top plate.
The first top plate or the top plate?
The bottom top plate or the top plate?
The bottom top plate first.
So the bottom top plate, right? So the first board on top of the studs that's running horizontal.
That's actually in conjunction with the layout board on the bottom.
That's right. So it's going to be
layout.
It's going to be built at the same time as that wall.
Or it's actually marked at the same time.
At the same time.
Right. Yeah, nail those together with some 8s, and then all the marks are the marks, and you just separate them and start throwing pieces in, and that pretty much knows that everything's going to be straight if you screw your wall up.
That's right.
So
and those are going to be split apart, and then those studs are going in between, and then they're getting nailed from the bottom and the top of those plates into the studs. And there's specific nailing patterns depending on the size of lumber that you're using, whether it's 2x4, 2x6, 2x8, how many nails you've got to have in each one. Or if you forget one and have to add one in later, where you're toe nailing those in or using brackets for them. There's not much else to say. The top plate's not treated. It's just standard lumber. It shouldn't be a finger joint. I guess it can be by code on that plate.
There's no
There's
issue.
nothing against it. It's probably not a great idea.
It wouldn't be very easy to deal with. It came apart on you.
Well, that's the thing is if you're shooting nails into it horizontally and you're having to worry about those finger joints and blowing apart,
that wouldn't be very fun.
It's not a great idea to have them. Although I have seen it there before. Houses I've walked through of some other builders here in Amarillo. But then we've got our top plate. Joel, you want to talk about the wall connections it makes and why we've got to have it?
Well, if you have walls intersecting with walls, how do they connect? Sure, you have ladder framing if you have a T section, so that wall is going to connect, but at the top, everything has to interlock. So that's what the top plate does. So, one wall coming this direction, that top plate would extend an additional 3.5 or 5.5 over the outside wall, and then you would be able to connect it that way along with the T.
And 24 inches is minimum.
For the leg laying
it out.
Right.
Yep.
So if you're intersecting walls, but so between that and ladder framing on an intersecting wall, it's pretty steady, connected. Pretty connected.
Of course, in the advanced framing, you could still use one top plate and use the mat and use metal ties.
And then you have to stack your rafters on top of the studs.
Yep.
Because that's not worth the hassle.
Well, the production framers it is.
I was going to say, I see lots of production guys do it that way. So
it makes their layout actually easy because they're doing 24s on 24s and stacked.
If they're good,
even if they're not great, Joel, because they're not. No, they're getting away with a really easy layout. It's 24s on 24s, minimal lumber, and they're stacking a roof rafter right on top of that wall framing.
Wall stud.
Mm-hmm. And
they just keep going.
And then they're using
and they're doing it with 2x4s. It's 2x4s and 6 joists, but it meets code.
Yep.
The only good thing about it is they do have minimal thermal. What am I trying to say? Not break, but bridge. They've got minimal thermal bridge on it, which is good for them, and that's how they advertise it.
Well, it costs less. The walls are wavy.
The walls are wavy. The walls are not as strong. They're not tied together as well, but they don't have thermal bridging. There's some things to it, and it makes sense.
So in production, I guess you were going small little footprints would probably be a good way to go.
Yeah,
it makes sense in production.
Yeah,
I mean, if you're doing 500 houses and
you're saving 40 studs a piece, 50 studs a piece.
That's right. At the end of the day, that'd be a lot more money than I make every year. So I get it. It's a game of numbers at the end of the day, and that number works for them. So,
and they only get a box and a half of nails, and when they're out, they're out.
So we've got the walls built up. We've got openings in the walls. We're moving on to.
Do you have your framers add the exterior sheathing before they raise the walls, or do you does it depend?
It depends. So if I'm gonna do a floor truss, at that point I would for overlapping. On concrete, no, I don't. If I've got a band joist, then it makes sense for me. And they'll toenail that 2x4 into the decking, and then use that to system to raise that wall up, or second story.
Mm-hmm.
Then it also kind of can make some sense sometimes. But if it's just on the concrete, no, they're standing those up, that they're squaring it off, they're getting everything trued up, and then they're applying that on the outside.
OSB, zip, whatever.
Never OSB, always zip.
I don't know. I've seen Joel do a couple of things that shocked me on the way it worked. So,
yeah. Well, we can get into that, but Sigma was a really beautiful install, and Tamlin paper, just house wrap.
Mm-hmm.
Well, it's not typical house wrap.
No,
I was totally blown away by what it was.
I would get away from zip, but if I got away from zip, it's typically to move to products that are more expensive. They're more robust, and I would enjoy using them, but it would, on my end, would cost more money. And that would look like some sort of pill and stick or a liquid flash.
Yeah,
I'd be happy doing either one of those. I got away from house wrap because there's not many people that detail it correctly. And I'm also one that I never really got super comfortable with it because I moved away from it quickly. Zip's been around for as long as I've been doing exterior walls. So it's like, why am I going to go learn something that I feel like is aging out when this has been proven it works? So even
territorial. That's why
even my experience as a builder, it's like, I don't know that I could detail one good enough that I would be real happy with it. So I'm not going to ask somebody else to do it.
You did have a framer that did understand.
We detailed it.
It looked right. Right.
I have a video I could show you, and it would stand up anywhere as this is the best install you've ever seen.
Yep.
They're
gorgeous.
I agree that
I almost didn't want to cover it up.
There's people that can do it. Yeah, there's people that can do it, and that's fine, and it's cost effective and it's effective.
But the thing with the zip is it's, I don't want to say somewhat territorial, but you just all over the United States. So depending, I mean, if you're going to stay here and you're going to build and it's a system that's working for you, that's great.
Mm-hmm.
Don't change, but I mean, I come from a territory where rain screen and wrap was the thing.
Now rain screen's code. You are supposed to be doing a rain screen, a 3/8 inch rain screen anywhere that we do it. Now with our cladding, with being brick,
Right.
it's a little bit different. But all these houses that you're seeing
Siding.
siding or ephes or stucco or any of that, yeah, it's should have
But you can actually get away with it with the wrap. A little,
some of the wraps you can.
yeah,
Some
they have it built into it.
yeah, some of them do.
But,
Got kind of like a dimple mat.
Yeah.
It's kind of cute.
But it works.
It works.
It works.
It
It
works.
works.
It's been proven, and it provides a drainage plane and an air path for it to dry out.
Sure.
That's the whole goal of a rain screen.
Top plate.
We're done with top plate. We're moving on to ceiling joists.
Ceiling joist.
Oh, ceiling joist. Here we go.
Ceiling joist.
Yeah. So ceiling joist, that's typically going to be solid sawn lumber, unless we're doing something specific like a trade ceiling, maybe a vaulted ceiling that's going to require.
Or trusses that have their built-in.
Well,
ceiling
we'll get the
joist.
trusses here in just
Oh,
a
so
second.
we're all
That's going to be
hand
its own thing.
Yeah.
We're on hand cut.
Is this
So
going to be a 3-part deal?
we got to wrap a lot of it real quick in the next 10 minutes. So
Yeah.
Raptors,
collar ties, purlins, and we're done.
and we're done. Yeah, and decking, sheathing, ceiling joist on solid sawn lumber. It's sometimes you'll see LVLs on big spans for special ceilings, and those are all going to be based upon the width that they're spanning. Whether you can get away with 2x6, 2x8, 2x12, 3 LVLs that are 16s, whatever it is. That depends on the span.
That's a heavy beam.
The loads that you're trying to carry. Going up from that, we've got all of our rafters, ridges, hips, valleys, to make up our roof section. And then,
Oops.
what's up?
We forgot to do portal framing.
Well, we might have a part 3 on this.
Okay. I mean, because we were talking about holes in the wall. We got
We are.
doors.
You're right.
We
Portal
never-
framing is important.
we
It
never
is
got our-
real
we
important.
never got our cars into the garage.
And let's back up. Let's go to portal framing, because I feel like that's probably the most, out of all the framing, probably the most
underappreciated.
it's probably not understood here very well.
It's not.
no.
No, we're still fighting it.
So let's talk about it.
Yeah.
Portal framing. Explain portal framing. What's the idea of it? What is it?
Well, you have a big giant hole in the wall now. I mean,
For?
What's that?
What's it for?
Well,
The big giant hole.
well, it's for your cars.
And what else?
It could be for anything, really. Why does it have to be for cars?
It doesn't have to be for cars, but it's
Nope.
specifically large openings that we
And
have
an exterior
on
wall.
an exterior wall.
Right. It's,
So like
it's a big old.
Tri-panel slider.
Yes.
Yeah.
Oh yeah. So we've been talking about doors and windows, but like I'm doing this next one, I'm doing these big quad sliders.
Yep.
So that's
a portal.
That's a
It's a portal.
12-foot hole.
Yeah.
Mhm.
So I guess what's the number that we have to jump into portal?
11 and a half.
Anything over 11 and a half?
Mm-hmm.
Okay. So
any hole that the horizontal span is over 11 and a half feet, that's when it moves into portal framing.
And so a lot of things come to play. You're not going to do box headers.
Nope.
Nope. You're going to think more commercially, I guess. And a portal is exactly what it sounds like. It's a big hole.
So would you?
Port hole.
We've been talking a lot about LVLs. That's something where you could get an LVL engineered or be told
You'd
okay,
end
you
up
need
putting
this.
2 or 3
A
in.
couple, two
Yeah.
or 3 of them in.
Mhm.
Or you can do steel.
That's what I was going to ask.
Yeah, I did steel on the last one. It was, steel's a good way to go.
Mhm.
Yeah, and technically, if you did steel, you could have an insulated header at that point.
Yeah, I did.
From both sides.
Yeah, I did I-beam on the last one. That worked out
Mhm.
really good. But let's keep it simple and talk about the garage door opening, because everybody's got garage door opening,
Mhm.
right? And most of them are, I guess, some are 9-foot doors, but like a double door.
Yeah, 18 or 16-foot door.
But
We got
it-
special hold downs on it.
Yeah, but it seems to me that even if you were going to do a double or a triple car garage, you would portal the whole thing,
Mm-hmm.
end to end. So
Unless it's staggered.
yeah, and so at the outsides of the garage, little wings, you got little wing walls. Let's just take a double garage door, make it easy, and you got the little return wings. Now those little concrete wings, there's a bunch of different engineering that goes into those. Not so much with slab on grade, and not so much with the seismic zone that we're in, but those units coming up to hold the opening would end up being structurally all connected as a U-shaped item. That's an easy way to put it. I mean, there's more than meets the eye on that one, but
Just kind of tight. Yeah.
Yeah. So you basically need to connect those so they don't have any kind of shear, any kind of rocking. That's kind of the important thing.
Yep.
That opening, and then there's some nailing patterns of the wall sheeting that go with it, bolt down of those little wing walls, some hardware where the wing walls meet this LVL system, and all those incorporated into this portal framing.
Okay.
With the houses that we see commonly now, the holes are getting bigger and bigger and bigger.
Mm-hmm.
Yeah, they are.
They are.
Yeah, they are.
Well,
that's
20-foot holes is uncommon.
Let's back up a little bit.
Oh, for sure, back. That was a quick one.
Let's talk about the sheeting patterns that we've got to have on
the nailing pattern, 6 and 12s, 3 and 6. And
the nailing pattern
3
on the
inches.
face is 3 inches on center,
3 inches on the edges as well,
Mhm.
on the exterior.
so they're talking about the nails every 3 inches. You want to see a nail.
Yep.
You know,
Which we get away with staples
Staples.
around here. We moved to galvanized ring shank, and I can tell you when you put a piece of sheathing up against a framing member and you're looking at it from the outside, put a staple in there and that sheathing doesn't really move. You put a ring shank galvanized in
it moves.
it sucks that up real tight. And so when you look at that and witness that action happening, there's no doubt that you're getting way more hole durability and air tightness out of a ring shank nail than you would be a staple.
does the code allow staples?
Yeah,
They do.
it
I
does.
don't know if I've done a bunch of staples.
It
Good for you.
again. You still got to remember that the code is still minimum.
Right.
So
It's the absolute worst that you can do.
yeah,
To legally be called a home builder.
exactly.
Okay, so then let's move on to the hardware, the straps that we've got to have. Go ahead and talk about those.
The Simpson strapping that goes across the tops.
Yeah, it ties in. So it ties in the header to the supporting.
Well,
the
you got to
vertical
go.
member, the
Yeah,
wing
you
wall.
got to go to the top plate.
Mm-hmm.
To if it has a double top plate, it has to go to the very top plate, and then it needs to come down past. If you're using LVLs,
Mm-hmm.
at least 6 inches below that LVL
To your
And-
stud.
to the stud,
Mm-hmm.
and it's got to be nailed. There's got to be a nail in every
Every hole.
hole.
And then hold downs.
We don't see a lot of hold downs
Yeah, we don't
here.
see-
So
Yeah.
that's something I think is probably coming because I know down south there we brought this up before. They're embedding hold downs into that concrete as like a strap that's buried into that concrete.
Yeah, it's,
Yeah.
it's a stab. It's a
For,
Mhm.
for right
24-inch
now, they can use a J bolt. They can use 2 J bolts with a 2x2 square
Mm-hmm.
washer,
flat washer.
and then a 2x2 square washer, and then a washer with a nut,
Okay.
and tighten it down. That'll meet the minimum.
So we're gonna talk about this for a second. We live in an area that is prone to high winds and tornadoes,
Nah,
and the
I'm
first
not-
thing that blows in is the
Is
garage, door. And what happens is it causes uplift on that house.
Correct.
So when you're tying your bottom plate in with a bolt to the concrete, your bottom plate's not going anywhere. But what's tied in to that bottom plate? Well, it's the studs. How are those tied in? With an upside down nail going into that bottom plate. So all you have is a 131 vertical shaft that's nailed into the bottom of that stud with no ridges, no ring shank. It's just a framing nail.
Yeah.
And so we've got our top plate strapped in with our header to the stud.
Right.
The weak connection there is at
At the bottom.
the bottom to that bottom
So,
plate.
so if you want to be a good builder, go buy yourself a box of A35s.
Yeah.
Have them in your truck, and then you toss 6 of them on each side and say, guys, I want these nailed at the bottom.
Yep.
Bottom plate to stud, and they cost you 50 cents a piece.
So that's
Little L
the
brackets.
that's the
Yeah, it's a
easy
universal L bracket.
that's the easy way to do it. But I think code's probably going to move to embed in that concrete on the
Either
support.
embedding it or using a shoe.
Yeah.
well, and if they embed it like an HTT with a stab,
Mhm.
then you're going to have to dig a footing. I mean, you're going to have those put into the footing 24 inches long before they pour that slab. So those are sticking out, and for them to attach this HTT that you're talking about that might show up.
Yeah, but
Yeah.
I'm seeing strapping done with one of our builders that still meets the minimum code that they're wet set.
No,
Mhm.
but that's what I'm saying.
so-
When it gets to the point where they start changing that up a little bit.
Yeah. And I think
You
you
know,
guys are right. It'll change.
I mean,
up.
they do make a strap that doesn't take the bolt. It's
Mhm.
actually a flat strap that's kind of kicked at a bend, and it it goes in
Mhm.
to the concrete footing, and then they kind of bend it out of the way while they're doing a bunch of different stuff, and then it comes back up and gets nailed in.
So I've seen them where on a garage wall, that garage door wall is not sitting on the. It's not sitting on the foundation, right? It's sitting on basically a stem wall poured on top of that
little mini
foundation.
stem wall.
Yeah.
So I've seen it where they've had embeds that go wet set into that stem wall,
Right.
and then once it dries, they bend them over, they frame on top of it, then they bend them back
and
up,
then they nail them on top of the sheeting.
and then
Right.
So
That's pretty common too.
That's another way of doing that. That's inexpensive. It's just
Yeah,
takes-
you just need two.
Just got to remember to do it.
Mhm.
That's
You just need 2 on each wing.
Mhm.
yeah.
You know, it's a good
And that's
way to go.
that's a little better than just strapping from the bottom plate to the stud, because then you can strap the bottom plate also to the concrete, and all that's being held in with the concrete.
But you know, when you're doing those, you're talking about these embedments.
Mhm.
You need more than 2 feet
Right.
because those embedments, that when you bend them up, they're nailing to 2 studs, not 1 stud.
Mhm.
So there's 2 studs there, and then the other side is 2 studs there, the corner,
Mhm.
and that doesn't all fit in 2 feet.
Nope.
Right.
So you need 30 inches to pull off a decent wing wall.
Yeah.
Just for the sake of
I think
engineering.
16 inches is minimum
Here.
for it, but
For the way we're doing them here, yeah.
Yeah,
Right. But
but
if you
it's-
start doing embedment, you need a 30-inch wing wall to
Mhm.
yeah.
play the game right.
Mhm.
Um,
So that's why I wanted to go back into the portal framing, because there's a lot of nuances in there. Some of it we're not doing, we're not aware of. We get by with kind of the minimum, and there's some things coming at us that they're probably going to change the way
No, I agree.
we're doing
I agree.
those.
it should.
It
they
it,
should.
it should, because
Nothing
that's
to it really. Just
what happens when we get that uplift is it separates from that bottom plate, and then the house is basically moved off of its foundation. That's where the big issue is. If these components are in place, yeah, your garage door might blow in, could have some sheathing damage and roof damage, but the likelihood of that lifting,
that hole's going to stay there.
yeah,
You can go right to the Simpson catalog and you can look right as a portal framing. They'll lay it right out for you.
it's like Simpson writes the code or something.
I think
Yeah, pretty much.
and you know what? I think that they're good. They're doing a good job of it.
Yeah.
Yeah, I mean,
Yeah,
I think they
have a good thought process, and they obviously want to sell
Product
product, so
that works.
They engineer the product that works. So yeah. Stick it in the hole.
It's a great brand.
Yeah.
We're open for them to sponsor the show.
Simpson, we're right
So,
over here.
Simpson and Lexo.
Yeah, you know what's going to happen?
we enjoy your products, and if you'd like to,
You want to give
sponsor
your
the
address
show.
up, then the next week we'll all have Simpson pins. They're going to sponsor us with 5 pins and a little tablet.
Well, I'll tell you what. We hadn't really got to the roof framing yet, right? We hadn't got to
Right.
hand cut. We hadn't got to.
We can do part
truss.
3.
Let's look at doing.
Another cliffhanger.
It's technically not wall assembly.
No, it is not.
But
And in the
true.
code book,
That's
it's
true.
separate.
so you know what? We're concluding wall assembly on this one, and then we'll talk about the roof on our
Yeah,
following
because
podcast.
Tim Hess wasn't going to do the roof.
No, it wasn't. There's a lot that goes into roof as well. A lot of nuances, a lot of things that aren't happening, and things that are happening that shouldn't be. And that's the whole point of we want to get this out so people can listen to it, understand the components and what they should be expecting and looking for, or how they should be trying to build. And that's what we were trying to do here, I think, overall. So
Yeah.
let's slow down. We'll spend some time on the roofing section, separate from the wall assembly. But I think we covered the wall assembly pretty well.
Yeah.
I think so. We might have a couple little trinkets we can pick up next time if we forgot something, but for the most part, I think it's there. We talked about Wayne.
Yeah, we didn't get much into wall sheathing, which is part of the wall assembly, but we might take it for decking and wall sheathing
together.
Oh, speaking about sheeting, when you're doing that portal framing,
Mm-hmm.
if you have a split in your sheeting, it needs to be blocked.
Yep.
And there again, your 3-inch nailing on that, double blocked. Whatever, little detail on that.
Yeah, probably not an ideal spot to split the sheath on your wing walls.
No.
Yeah.
But you don't have a choice sometimes. And then there is another little engineering formula, depending on how we don't do it here, but when you start getting into stem walls and you start getting into engineered portal framing, depending on how wide it is, that stem wall that we see, that little 2 or 3 inch stem wall you're referring to, it might come up 3 feet.
Sure.
And then you'll just sheet over it and it will kind of disappear. And in doing that, there's a whole little program to get your garage wrap attached a certain way. Otherwise, you got concrete hanging out, and there again, it's not pressure treated. And So if that ever does come around, there's a.
I don't
formula.
I think until our seismic changes,
You won't see
and
it.
I don't think we'll ever see that.
It's interesting because seismic. I mean, the first thing you said before we were on air is, "Well, geez, you're sitting in Tornado Alley,
right?
Don't you think that it should be a blend between seismic and Tornado Alley?"
I'm not disagreeing with that at all.
Some of the practices that I've done in seismic, I'm feeling now after listening to what happens around here, what you're all talking about, is
you ought to be practicing
the
some
same.
of it.
It's the same.
It's almost and there are. I think Fortress is one of them where they talk about a fortified roof program, and that has nothing to do with seismic here, but it has a lot to do with wind. Every bit of it, tornado and wind, and keeping that roof attached. And
I know the only one I even know of, which I think is partnered with Fortified, is the whole Zip System family.
Yeah.
Which I know once you get a fortified roof, you can get insurance discounts and things like that as well. I think it should be, if it's not realized by our realtors here, the house should be valued at a higher, it should reach a higher value with that certification, but it is expensive. It is expensive. We'll get into that on the next one, I guess. Cool. Anything else we want to touch on? Joel, when you were building over on the coast, did you guys ever have anything to do with like breakaway walls, or is that more of a East Coast hurricane deal? Or
I don't know anything about breakaway walls.
Florida's
got a bunch of them where there's
Mississippi Valley's got some.
Yeah, if like tide comes in, floods the house, it's designed to, in a simple context, it's designed a section of that wall would basically fall out so that water can flow through the house instead of carrying the whole house away or breaking the whole house down. I didn't know if that was something that y'all did on the coast over there.
No, I think it wasn't just so recently. I even saw these tsunami signs finally show up, but we didn't really have a big flood thing. And I was pretty far in from the coast anyway, across the mountain range. So I wasn't going to get any flooding. I mean, there was flooding. Yeah, I mean, there was flooding, and we, houses would have drainage and stilts in here or there. You would see in a certain little area, little creek area that's prone to flooding. I did think of one more thing on the portal framing. Maybe used them once or twice, but Simpson makes. We were talking about Simpson.
Oh yeah, their portal frame system.
They make a portal frame system.
Yep,
it's expensive, but it's pretty.
I've seen them one time.
Yeah, it's pretty cool. So those wing walls we're talking about, kind of putting everything together, you actually get you order a section of wall framing made,
and they come from California. Imagine that, right?
Yeah, and then you just bolt it in place, and it is portal framed. Nice.
That's pretty slick.
Nice setup, but you will never see those here. Nope.
Not that now we won't.
Maybe your
since Robert mentioned they came from California, we really probably won't see them.
Well, I've only seen one set since I've been inspecting, and that's where you got them. They came from a California warehouse.
Before we completely wrap up, there's a couple of things we want to plug. We've got a home that was built by the Builder Association that we're now raffling off.
Yes.
So tickets are $500 a piece.
Yep.
There's a maximum of 2,400. And I don't know how, I'm just talking here. I don't know if we can even say this or not, but the minimum we've got to get to, I think, is 1,200 before they sell that. Yeah. So there's even a possibility of a 1 in 1,200 chance of winning that house.
However, in Pinnacle.
Yep, over in Pinnacle. However, we have to say 1 in 2,400 is the actual chances of it. It's in the Pinnacle neighborhood. It's a 4-bedroom. Is this right? So. 4-bedroom. Anybody know that? 3-bath?
25 to 2,600 foot.
Yeah, it's a really nice.
It's a nice house.
Really nice house.
All landscaped. It's ready to go.
It is. It's a good new upcoming neighborhood. That's it's K through 12 walking distance. All in that neighborhood.
I think there's 12 phases altogether, and this is phase 1. So you can get in that house for $500.
For $500
anyway.
And historically houses just increase in value, so it could be
it might be worth $600 next year.
So if you guys are interested in that, get a hold of anybody in the Builder Association or
go online.
Go online.
Facebook. Buy a ticket.
Yeah, absolutely buy a ticket. We still have another house that is for sale, and it's on the MLS listing. So if that's something that you guys want to look at, take a look at that. We're done with luncheons for this year. We had our last one this week. So the next one will be in January.
Yeah.
We'll have what else we got? We got a couple events coming up.
Oh, the banquet's coming up in November.
Builder Association banquet, new installation banquets coming up, I think November 15th.
If you need a ticket for that banquet, Jordan will buy you one. Free dinner.
Well, I don't know about buying the banquet, but we can give some hats out maybe. And
Yeah, there you go.
And if Simpson wants to sponsor us, we got pins and paper coming.
That's Simpson and Sashko. If you guys are out there listening, we'd be happy to have you as a sponsor. We are looking for sponsors still.
I'll be seeing somebody you might.
Yeah, so I know the three of us are going to the Build Show live here in a couple of weeks, and we'll get to see a lot of those sponsors we're
We'll
looking
come back
at.
with some free hats, no doubt. We'll all be wearing hats.
Yeah, they'll be free, but they won't. I don't know if we'll be able to
That
get
thing's
it.
really free.
Depends.
Yeah.
Anything else, guys? Before we wrap it up,
We talked about spray foam earlier today,
We
about
did.
the wall up in the attic, that separation wall
Mhm.
from the garage side to the condition side. Doing plastic or landscape
netting.
whatever, and spraying against it. I just
About to be a
heard
thing of the past.
it's going to be the thing of the past. The Spray Foam Manufacturers Association has said absolutely not. We want to see it encapsulated.
Mhm.
So you're going to have to run a 2x4, 2x6 wall, whatever you're doing, and sheetrock one side, OSB the other, or whatever you choose to put up there like that.
Mhm.
So
That's a big change.
yeah, it's a big change for fire and ignition barrier.
It's not a big cost
But
difference.
that's what you told me is the cost.
That's
wasn't
something that we've done for a while, is carry the zip up into the attic space,
it? Yeah.
tape that, use it as the primary air seal. So try not to use foam for air seal. I use it as addition to, but not the primary.
Right.
So, I mean, it even using zip and not drywall, it's relatively low cost because it's not that much material. It's just the thought of doing it.
And making sure they get it done.
You don't want to wait. I can tell you now, you don't want to wait until the house is framed and then try to do it, because chances are you're going to have
16-inch pieces.
you're going to have purlins and kickers coming down in the wrong spot that make it really hard to do. So if you can basically carry that wall up before you even get the roof framing on, it does make it a little bit easier. That's just kind of a pro tip, I guess. Been there,
Yeah.
done that. Had to cut around.
too much
So I say you have 16-inch pieces, you'll be look like a puzzle piece.
You're
when
exactly
done.
right.
That's what
And
you
then you
end
got
up with.
then you got $400 worth of tape taping them
And
together.
nails, and
Yeah.
then you got to fall through anyway.
There's all kinds of changes occurring. So we'll kind of visit about some more of this stuff as we move forward.
It's good.
And
It's good that we got you on our side, giving us the insights and what's to be coming.
yeah, unfortunately, I know
You're not
every-
wearing your official energy ambassador t-shirt.
No. They
No.
haven't sent it to me
I
yet.
see.
So
Well,
that's okay.
Joel, you got anything else?
No, I think that's a wrap.
That's a wrap. Ben?
All good.
I think
All
that's
good.
A,
That's a wrap.
I think that's a house wrap.
Uh-huh.
Sorry.
All right. Until next time, thanks for joining us with the TPBA Builder Talk podcast. Next podcast, we'll be bringing up the roof assemblies. Feel free to reach out for sponsorships, or if you'd like to be a guest on the show. Thanks for joining us.
Thank you.
Later.
Later.